Yes, what about the next one? 7120 north to 8645 north over the North Pole.
Okay.
Let's do that. What are you asked to find out?
The latitude value, change in latitude value.
That's right, chilat or dilat. And the points are on 7120 north. And the next is 8645 north. Both are in the northern hemisphere.
Northern hemisphere. 7120.
The locations doesn't really look relatable. I'm just drawing to parallel latitude. 7120 north and 86. Yeah. 45 north. So if the question stopped there, like 7120 north to 8645 north, then how will you find out the chilat? The chilat would have been 8645 minus 7120. That's going to be a chilat, right? So here the chilat between 8645 north and 7120 north is going to be 8645.
15 degrees and 25 minutes.
7120, that's right, that's 15 degrees and 25 minutes. Alright, so depending upon you're traveling from 7120 to 8645, it's going to be a northerly change. And if you're traveling from 8645 to 7120, it's going to be a southerly change. Let's go in the order given the question. It is given 7120 and 8645. And 8645. So you're moving from 7120 to 8645. Therefore, in what direction is the change happening?
Northern.
North. Therefore, the chilat is basically 1525 north. The change in latitude is happening in a northerly direction by an amount equal to 15 degrees and 25 minutes. If I want to convert this to corresponding distance, I can do that by multiplying 15 with 60
260
and adding 25 with it, right? Well, that's going to be 1015.
Yeah.
No,
It's 925.
925 minutes. And can I convert this 925 minutes to 925 nautical miles?
Yes.
Can I apply this conversion?
Yeah.
Yes, I can, because I will be traveling along a meridian, right? Therefore, it's 925 nautical miles, right? Happy with all this? Now, what is asked the question? The question has a bit more to it. What is it?
It is over to North Pole.
Over the North Pole. So that's the difference there. If the question did not say about that, this is definitely the answer. 1525 as far as chilat is concerned, and the distance is 925 nautical miles. How is the question different now? How is this going to be different?
It's different, like these points are not exactly the antipodal points, but they are like one is towards the prime meridian and another one is crossing the North Pole and behind
That's right.
the North Pole.
Exactly. So you start from here.
The point which we have marked here at 8645, it is towards the southern side.
That's right.
Sorry, western side. Yes, this is the point where.
So we have still traveled between these two latitudes, but now we have traveled through the North Pole. Even when you reach here, you are again still on 8645 north. But then here there's a significant difference because of the chilat, change in chilat, and therefore the distance is also going to change. They're asking you about this particular change in latitude. So now you know how to find out, right? Disconnect this, and this is where you start from. This is where you end. Right? So you're looking at this angle rather than this angle which you had initially. So initially you had the smaller angle which we measured as 1525, right? Now we are measuring this total angle. So how much is that? This is going to be 71 degrees 20 minutes. This is going to be 86 degrees 45 minutes. Total being 180. It's 180 minus 8645 plus 7120.
It's coming 21 degree 55 minutes.
Yeah, so this is the chill at between 71 degrees 20 minutes and 86 degree 45 minutes north. Through North Pole is 180 minus 7120 8640. Yes, how much do you say?
It is 21 degree 55 minutes.
55 minutes. Now, in what the direction of travel?
From point, like, what are the main points? Name, sorry, points name. We can take P and Q. Yeah. So from P to till pole, it is northern travel, like northerly direction, north
That is
direction.
360 degrees is the track.
Yeah, 360.
Right.
Yeah, 360 degrees of track. And
Yeah.
from true north till Q, it is southerly track.
180 degrees. So all these are tracks, huh? All these are tracks. There's no heading, nothing here. It's all about your actual path on the ground, which is always your track. Right? Your track is 360 does not mean that your heading is 360. Heading can be anything else. So we'll see that later. But as you can see, there is no fixed direction like north here. It's initially northerly and then becomes southerly. Now, what about the distance? Distance is not asked in the question. We are just doing out of curiosity. Distance will be 21
degrees multiplied by 60 plus 55.
plus 55. So it's 1260 plus 55.
It's 1315 minutes.
1315 minutes. Now we'll take a pause here and see whether we are measuring this along a great circle. Yes, because it's meridian.
It's possible. Yeah.
So 1 minute is 1 nautical mile.
It's 1315 nautical miles.
What about top view? This is the
Top view.
side view.
Oh, okay. Top view, we will have two these concentric circles.
Two concentric circles. Yes, very good.
One will be, this one will be of 8645. Another one will be from 71 and 20.
The bigger one will
We can
be.
take. Yes, sir.
The bigger one is going to be 71.
7120.
Yeah.
And this one will be 8645.
Okay.
Now, from 71 to 120, from any point we can say yes. So we'll.
It will help you if you can draw the references first. That's going to help you easier because otherwise you will struggle locating these meridians. So the meridian is not specified here. It doesn't really matter because if your track is actually passing through North Pole, you will actually enter your anti-meridian for sure. Right? So here,
We can consider prime and anti-prime meridians also.
anti-meridian. Right? Now we assume that we are going through a shortest track. What if I, so this is 7120, this is the point P. This is point Q in the first case, right? The second case, we passed through North Pole and we reached point Q here. What if I tracked like this? I reached from here, I'm tracking all the way. Instead of tracking straight, I track like this. What is my chill at now?
Your chilat will be the same only
The same.
longitude.
But I won't be able to do this
Yes.
because that is not going to be the shortest track. Yes, but no worries, let's not put that. But as far as we are concerned, it's still at here. So we are looking at a track like this from P through North Pole till Q. Right, this is the top of the side view. This is the top view.
ये क्या
62 degrees north and 93 east and 62 north.
got it. What mistake I did?
West. So these 2 points, you can see they are on the same lat. And if you add the longitude, they add up to form 180 degrees with opposite sign.
Yeah.
And therefore, they are on the same lat and they are on a meridian and anti-meridian. Remember, this does not mean that it is antipodal. So don't make a mistake there. It can be antipodal only if the signs are opposite. So that's the only difference, but that is a difference, right? So let's draw the circle. Okay. So you can see this, the points are on a meridian and anti-meridian. In that case, the shortest track will pass
through nearer pole.
That's right, through the nearer pole.
Sir, is the answer 3360?
That's right, yes. So where do you want to go wrong?
Actually, I made a silly mistake. Like in putting up the values in calculator, I messed up.
You went wrong there. Okay. So the side view is the one that is better for these kind of questions where you have a meridian and anti-meridian involved. And so if I take this as, so definitely I can take 87 degrees west here, even though it is east. It has nothing to do with that. I can still take it.
Yeah.
Right, and this I can take it as 93 degrees east, and we are on 62 degrees north.
The same.
Right, and we are, what is this point? This first point is 62 degrees north with 93. So I can mark this point as P, and this is Q. So 62, 93 over here is point P, and this is Q. 87 is for Q. So you're traveling from P to Q. Definitely you can see shortest track will take you to the nearer pole, and without even calculating the angle, it is pretty clear that the nearer pole is going to be the North Pole.
North pole.
Right? Now, to find the angles, it's all at the center of the earth. What we measure the angle and what we want the distance. We're looking at this angle corresponding to an angular distance of so much. So to find this angle, we have these two angles available, which is 62 degrees each. Right? Total is 180. Therefore, this angle will be 180 minus 2 times 62. How much is that?
56 degrees.
56 degrees. Degrees is the change. You can see if since you're traveling from P to Q, the initial track is northerly, and after crossing the North Pole, it becomes southerly. How will you find the distance? Are we measuring along a great circle? Yes, so it's easier for us. Right, so the distance is going to be 56 into 60. That is
3360
minutes. Now take a pause and we'll think again. Yes, we can do the conversion straight. And therefore this is 3360 nautical miles. It's a very commonly asked question. Now, if you do it multiple times, if you understand the basics, then you will understand automatically that it's going to be 180 minus 2 times latitude. Right? And you can now find out the distance. 3360 kilometers. Multiply with
1.85.
that is how much?
It is 6,220.
622, so roughly double.
Yeah.
Right?
Yeah.
Yes. Perfect.
Sir, in this particular question, can we do it using the departure formula?
Departure formula? Yes. Departure formula can be applied anywhere.
Yeah.
Even at along a great circle, you can apply departure formula. Only thing is that your cost value is going to be 0. Now, departure equation has a problem. The equation is derived in such a way that the departure equation. What's the departure equation?
It is change in longitude.
So departure in nautical miles is equal to change in longitude in minutes.
Yeah, in minutes multiplied by cos of latitude.
Cos of this is where. So it is a It is a particular
Latitude.
parallel of latitude. So it has to be a parallel of latitude. So if you measure it along a meridian, what value will you give here?
62 degrees for particular arc is.
But are you sticking on to 62? You are starting from 62, you're going somewhere and coming back to 62. But you're going through 63, 64, 19, reducing, coming back. So you cannot apply departure equation here.
We are first rising 62, 63,
Yeah, to 90.
80, and then reducing 90, 80, and then okay.
That's right. So we cannot apply departure equation here. That is why it is through a particular latitude. That's why we use the normal equation, great circle conversion here.
It would have been okay if we were traveling from P to Q, not over the pole, only from this point to this point, along the particular parallel of latitude. Then it would have been.
That is when we use departure. You cannot even use departure if you're traveling from, say, a point here 62 to a point here 45. When you depart from a parallel of latitude, you cannot use departure equation. It won't work. What you can do is, you can probably find out the mean between these two, 62 and 45. And then you can put the mean here, but that is going to give you the departure, that is this distance along that mean latitude. It is still not going to give you this one.
Exactly.
Right, so we will do a couple of questions where you need to find out this distance. We will see how that is done. It's just Pythagoras theorem, you can still use it.